Hello guys, welcome back to my YouTube channel. Um, Today we'll be dealing with a factor of safety. This is strength of material N5, right? So here we have a factor of safety. Uh, when design when design engineers are designing a machine with its many components, they always include a factor of safety in their calculation. The factor of safety tells how much stronger a system is than it needs to be under a safety load, right? So for an example, you've given us if a cable indicate the maximum load of that and the factor of safety is 2, the cable will break when the load is that will be multiplied. The factor of safety is 2. Usually you double that thing there. So what they're trying to say, the engineer they try factor of safety is allow the importance of factor of safety. What do you think will happen if electrical engineering design and aircraft winds to be strong enough only for good weather and perfect flying? Okay, so factor of safety is very important. Is very important. Imagine if you are designing a car and then your car is made to carry 4 people, 4 passengers, then suddenly you decide to do overload maybe 5 or 6 passengers. Then what about when you are driving on the humps and bumps? So in other words, the factor of safety is that preventing that our object to reach the maximum stress is doubling what the maximum stress is expected, so that will increase the safety as far as possible. You can read it about the safety of safety. You'll see why it's important. You can do research, but it's not the same thing which is that it's not that much thing that you have to. But on your textbook is there. You can start it on your textbook. You can read it from, if you're using the new syllabus textbook, is there from page 37. You can see why it's important to have the factor of safety as an engineer, to know that, to include it in our calculation. Okay, so nevertheless, the formula to calculate allowable work stress, we calculate the allowable work stress as follow. Allowable work stress will be equal to ultimate stress divided by the factor of safety. Then it says here, however, a material is usually limited to having elastical, so a more practical limitation of elastical design yield stress. Therefore, okay, we have given there the yield, what I'm doing, we have given a yield stress, over factor of safety there. The stress, so the allowable the working stress is there. You see, we have that in these formulas to them. So working stress is the allowable working stress in Pascal. Yield is the yield stress in Pascal. FOS is the factor of safety. As you can see, factor of safety, you can see we have these two formulas we'll use to calculate that. Let us put this formula into practice. Example 2.1 says a steel bar must transmit a tensile load, which that is force, that one, of 100 kilonewton, right? Then this is calculate the diameter of the rod needed when the ultimate, you see, you're given the ultimate, what's coming in your mind, the ultimate stress is 530 megapascal. If no factor, then if we first if no factor is, if no factor of safety is used here, we exclude the factor of safety if it's excluded. So okay, this one, that means it's a direct. We should calculate what the time need when now is excluded, that means we'll use the direct. This will be a direct stress, which is force over area without effect of safety. Then we can make A the subject. This will be force divided by stress. Right, then area is pi over 4d squared. That there we have force over that. If you want to make d the subject by its own, you'll divide by pi over 4 both sides. This and this will cancel. This will be if you divide like that, remember this is same as over that thing. This will be then inversely actual will be pi multiplied by 4 like that. Then it's d. Then d is simply f for strength there, pi like this. Right, that is what we'll have there. So we can substitute what is force. Force we are given 100 kilonewton. Then the stress is that 508. Okay, force 100 kilonewton times 4 divided by, oh, this is not 6, do not think it's 6, it's just the stress there, which is we have given again 508. If you have seen, kilopascal times 10 to the power of 6 multiplied by pi. Mathematically this and this will cancel there, these two and these two, but anyway you can just punch this all that on your calculator. If you punch that, you'll get that your diameter will be will simply be equals to what? Will be 0.015 meter. This is what I have. I don't know what to, let's say someone, or I don't know if we are, if you did the scientific, will be, it's up to you. Maybe someone says the scientific form will be that 499 times 10 to the power of minus 3, whereby it's in meter. But however, if you want this in millimeter, there is no need to multiply by 1000, because we have already have this is equals to m. Then we have also that, then this will be in millimeter. I don't know, maybe you've used this, which is fine, no problem. If you, I know most of students, others, they like scientific, there's no problem about that. So here they say they want if or diameter when a factor of safety of 5 is used. So now the factor of safety is used. We know the working stress will be ultimate divided by the effect of safety. The stress will be have ultimate divided by vector of safety, whereby the ultimate we have given 530 divided by 5, and this punch that will be 106 megapascal. Then remember, this is what is the, we have included the factor of safety. Now we have, that is what we're supposed not to reach, but now we have the actual one we're supposed to use. Then the actual we know is force over area. Then we find the area to be Right, if you want to calculate the diameter, we're still going to use the simplified one. I did the subject, remember. Therefore area will be equal to this. Diameter will be equal to this. If you do your subtractive formula, therefore, then the diameter, let me not include, therefore is not the final answer. The first there, 100 times 10 to the power of 6, it was 3, or it was kilonewton, times 4, divide this by the stress that we have there, the actual one, 106 times 10 to the power of 6 multiplied by pi. Then you have to find this. If you calculate this, your d will be equals to over you see here, this is 3, so do not make this is 3 there, and 10 to the power of 3. So here I got 0,0346, but if you want it in scientific, you'll press shift, which will be 24,658 times 10 to the power of minus 3 meter. Then in millimeter is 34,658 millimeter. So this is how we go about to apply our factor of safety. This is how we go about to calculate our factor of safety. So nevertheless, guys, thank you for watching, and please, once more, please subscribe to my YouTube channel and click that notification button. Subscribe there to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. And then thank you for watching, guys. All the best. Then stay tuned, as I'll be posting some new videos there.